in normal PL/SQL terms, we will index the table so that the retrieval of the data will be faster.
Okay.
Just it will be, I mean, it will be maintain the index of the column that we define as part of the table definition, and it will have, so instead of scanning the whole table, I think it will using.
Okay, so we didn't discuss about indexing, right, before?
No.
Okay, so the main purpose of the indexing is to search easily, to fetch the records easily, right? So if you have, let's take a very simple terms, like we have array, right? In array we have indexing, correct? Each array we have index, right? So based on index, what we will do, we can easily fetch the record, the specific position. The same way here for each table we can create a specific index for the specific column. So how we will create index based on our requirement. Let's say I'm going to write a frequent queries on the specific column. I'm going to write a frequent queries on the specific column. So based on that the question, based on that query which I'm going to write on the specific column, so I'll be creating index for that specific column. When I create an index, what will happen, it will create another table, index table, and it will maintain that record with indexing, that record with that column with indexing, the original column, the column which we need to what we need to deal or we need to query, right? So because it's maintaining a different column, different table here, so the original data will not be impacted. The original data will not be impacted. So when you are querying, what will happen? Let me draw here. Let me make use of this. Look at guys here. So I have a table called I have a table which has employee ID. I have a table employee ID. I have a table employee name. I have a table salary. So now I'll be doing more aggregations or aggregation functions, whatever it is. I'll be more querying salary part. Let's assume that I'll be querying more salary part. So like what is the average salary, what is a more salary, greater than salary. So that's such kind of things I'll be doing. Okay. So what is my query column here? The frequent query column, salary. So in the salary column, I'll be writing, let's say I'll be finding average, or I'll be finding I'll be finding who is more salary. So I'm more interested on the salary column here. So then what I will do, I will create index table on this. I will create index table on this. When I create index table on this, what it will do, it will maintain a table. It will maintain a table for the specific column. There are two types of indexings. One is a compact index, other one is bitmap. There is a slight difference between these two. I'll show you the document. We can discuss on this. So in the salary, what will happen? It is maintaining the different table. The querying, while you are querying on the salary, no need to scan your employee ID, employee name at the time of your querying. So it will directly go and check whether this table has indexed. So when you're querying on the salary, what will happen? Select star from employee, where select average of salary from the employee. Let's assume that. In this case, first the query will check, is there any index table for that specific table? If it is there, yes, directly it will come on query on the salary. I mean the index table. The index table, it will not query on this original table. What is the advantage of having an index table? The advantage of having an index table is the query results are faster. The query results are faster because I don't need to query, I don't need to scan other fields. I don't need to scan the other fields. If you guys know how the scanning will happen, so when you execute a query, the scanning will happen this way, horizontally. The scanning will happen horizontally, each and every. Then it will find what is your where condition clause column. Then it will happen this way. Then it will find the specific columns. Right? So if you have an indexed query, if you have an indexed table, I can say if you have an indexed table, the query results will be faster. The query results will be faster. And also it doesn't mean that if you have a multiple query, multiple indexes on the same column or same table, again it will degrade the performance. Because when I query, if it finds the multiple indexes on this, because as I said, there are two type of indexes, right? Bitmap and compact. Bitmap and compact. So if it has a multiple queries, what will happen? Multiple indexes, what will happen? It will try to look for which index has to choose. That's the one, and it has to go through those index, right? So it will take a little time. The more time will take. The main goal of your indexing is to improve the speed of query and look up on the certain column for the table, right? So we'll be creating index on the specific column based on our query pattern. So I'm more interested on the salary. I'll be writing more queries on the salary. So I'll go with the salary. I'll go and create the index on the salary. Is this point is clear? Is this point is clear? You can create an index, you can drop an index, you can alter an index, all these options are available as like your partition. Let's see a simple example how to create index. Let's say a simple example how to create index. Create index, which index you give index table 1. Let's say we table 1, a sample table, whatever it is. On, you should specify which table you are going to create. On employee here, on employee, on employee, and which column you are going to do that. Salary, salary. So as I said, there are two type of indexes. One is a compact and other one is a bitmap. We will see the difference between the compact and bitmap little later. Compact, bitmap. There are two type of indexes, so we'll be specifying here which index I'm going to use here. Which index I'm going to use it here. Understand? Understand? Compact with redefine. So deferred build rebuild. It is a deferred rebuild. Deferred rebuild. So this is the index you have created on salary. This is the index you have created on salary. So whenever you query on the salary, let's say sum or average or anything. So first it will go and check the index table, and it will call that index. Just back. What we have done, we have already has an employee table. So we already have an employee table in the our database, which is test 550 530, and we are created index. Now create index name, and this is we have created. After creating this, and I'm going to query the existing table without index. I'm querying average on the salary without creating index. So it is taken 55 seconds, right? 55, close to 56 seconds it is taken. Select star from EMP, floor from EMP, select, spelling is miss. It has hardly 1 2 3 4 8 records are there. Hardly 8 records are there. It's already showing 8 records. Hardly it has 8 records. It's taken 56 seconds. Now I'm going to create index on this. So let's check how much time it will take to this for the same query. What is happening this? They cannot recognize input sal, the table name, nearby the table name. On table, sorry. On table, here we missed EMP. We missed EMP. I'm creating index. The index has been created. The index has been created. Now query that salary the same with the same. Select star the select AVG of the salary from EMP. Now check how much time it will take. Now check how much time it will take. Now check this. It's actually launching a MapReduce job. So the MapReduce job is taking. What is your key here? Your salary is the key, right? So the salary is the key, and it is going to execute a MapReduce job, and based on that, salary is the key. It's also taken almost the same time because here we have no the single node cluster. We may not able to see the huge difference between these two. In the real time, yes, it will give a exact less performance only compared to the. I mean, less performance means better performance will give the without indexed table. Without indexed table. Okay. So let's go to our drive. I think we already have a drive here. Nodes, Hive nodes. We have something here, index. Where is it, index? I didn't share index here. Let's see, indexing is there. Okay, this is the document for indexing. This is the document for I mean, here you have a partition example as well as index. Both are there in this. Let's go for indexing part. So bucketing, how to create a bucketing, how you this, and sampling, bucketing, and all this there. Let's move a little down, indexing here, right? So here we are going to see what is the purpose, when to use, what is indexing, and why index. All the details are there. When to use indexing if the data is very large and the query execution is more amount of the time. If it's taking more time to execute a small query, and if you need to improve performance of your query, we will go with it. And types of indexes, there are two types of indexes. One is a compact index as bitmap index. And this difference between these two, see, the compact index will not only keeping a data in the table, it also keeps the information of the block, which block these records are there. So let's say the data will be divided into blocks in the HDFS, right? So when you create a compact index, what it will do, the data means it is a records, right? Ideally the records are each row. So which record is there in which block? So your compact index stores the pair of indexed column value with its block ID. So your index, when you create a compact index, what is happening, which block I need to go and get the data? You no need to it's no need to get like scan all other blocks. So directly go to which block my data is there, you can fetch the record from there. So look at guys here, the main difference in this storing of mapped values of the rows in different blocks. When the data inside a Hive table stored by default HDFS, they are distributed across the different nodes. That's true, right? The data will be distributed across the multiple nodes, right? There needs to be proper identification of the data, like the data in the block index. The data, if it is in the block, okay, block index. So this data will be able to identity which is row is present in which block, so that when the query is triggered, it can directly into that specific block and fetch the record. Directly can execute on that specific block. So while performing a query, it first checks the index and then go directly to the specific block, right? So bitmap index stores the combination of indexed column value and list of rows as a bitmap. Indexed column value, the column value, what are the column you have specified, like a salary, whatever it is, and list of rows, how many rows are there in the map, in the bitmap. Okay, so that you have options to create index, show index, alter index, drop index. As I said before, you can create index, and you can create index, and you can no you can drop index, you can show index, you can alter index. So here the simple example it has shown with on Olympic data. The Olympic data, there is something called age, as we have seen in the salary. Without creating index, we have performed selecting the average, and it is taken some time, some in the some good amount of time. 21 seconds, let's see here, 21 or 22 seconds. After creating index, and we have queried the same table, it has taken 17 seconds only. So we have seen the little difference there. Difference there. So whether what type of index you are using, if you want to know that, we can know that. How? So we have something called describe table. The same way we have something called describe index. Let's look at guys here. Describe formatted index on which table it is? EMP table. No, EMP underscore index, right? What happened? Table or index not found for this? No, that's we have done something mistake here. The mistake is forgot index on this table. Parse formatted of on table index. Describe formatted index on EMP. Show, okay, this is not this one. You cannot describe it. Let me say show in this case. Method index on EMP. Yeah, it's showing. Okay, not describe, I think show. Describe command is there. I'll check. So what is the index you are using, and which table you are using, which is a column, what type of I mean indexed table name, and what is the type of index it is. It is a compact index or bitmap index. So the same way we can also create a bitmap index. So for the bitmap index, let's copy this. We need to copy this. We need to specify as bitmap, and let me check from which package it is. I forgot from which package it is. Let me check that. The bitmap index is from
Veera?
yeah. They tell me.
I mean, this index creation, right? So will it at the background it will create any in the HDFS system? Does it create any mapping kind of thing or anything like that?
Yes,
Internally?
it will create. Yes, it will create a table background. That's what when it says show, it is showing this name, right?
Yeah, table.
Mm. Mm.
At the background, HDFS it will maintain some layer, right? Something.
I didn't get you.
I mean, in the HDFS, does it maintain anything for the mapping of
No,
this
it will
indexing?
not maintain anything in HDFS.
Okay.
It's logical, right? Actually, it is. I can say like it is. It will create this metadata information in the meta store, which is in MySQL, right? Okay, let's see here in this case. Okay, let's go and see. Let me show in the HDFS what is happening. Go to your this and go back. Slash user slash hive slash warehouse slash warehouse. In this way, ours is test db this, and let's look at here. You have emp index emp, right? In this, nothing is there. Is there any data here? Nothing is there. Did not get anything. Did not store any data in this physically. On existing data only, it will create. It's kind of a logical. So instead of when you create index, it will not query whole data. It will query only the specific column based on this. This guy will maintain that mapping in your meta store.
Okay. Okay.
Okay. Clear, Madhu? Still
Yes,
you have
Veera.
a doubt? Okay. Yeah. So look at here. So you'll create as a bitmap. Okay. So here you don't need to specify any as or handler and all. You can just directly go ahead and specify the bitmap. Bitmap. It's already available. I'll say 2. So let's execute this. And it's created. You can execute salary on this. It's launching a map reduce. Actually, in our case, it is taking a little more time because it has to identify whether index is there or not, and it's going query. But in the real time, it's not. It will take a very less time comparatively non-indexed table with the index table. When you compare with the non-indexed table with the indexed table, it will take less time only. 32 seconds. See here. So before we were having a 50. If you see before, it was 50. Now 34 only. Actually, it is showing a better performance than that, right? See here, this is not. This is before creating index. Select star. Let me show you that on 50. I think 56 or 51 we have seen, right? The time it was 56, right? After creating index and also in the compact, it is shown the 56. Now see, it's a 32 only. So much of better performance is there. right? Your bitmap will give a more performance than your compact. That is for sure. Bitmap is maintains the table, and if you go and look at in your database, your HDFS, look at here, index 2. Is there any data here? It will also not show any data. It will not also didn't store any data, but the mapping will be there. The mapping will be there. Suppose if you want to drop any index, you can drop using the drop command. You can use the drop command. From here you can drop the index and index name and which index you want to drop. You can drop it. So if you execute a show index on specific table, there are two indexes. Before it was only one index, now it's two indexes. Before it was a bitmap, now it is a, before it was a compact, now it is a bitmap. Clear about the indexing? We can create indexing. So the question from the interview will be hearing, can we create indexing on the Hive, in Hive? So if you are able to create it, what is the advantage of the creating index, and what type of indexes are there? There are two type of indexes, the compact and bitmap. Are you guys clear about indexing? Altering, and also you can do that. No, whenever you create indexing, we will execute alter index, and we will do on which table we will rebuild it. So we didn't execute alter index. So let's see, after executing alter index, is it showing any better performance or not? So before that, we will drop one index. We will drop one index because we have a two indexes here, right? So let's drop one index, right? Let's drop one index. Drop index if exists on, no, you can specify the index name. You can specify the index name. Let me see the query one more time. Drop index if exists Olympic index on this. Yeah. Let's say I'm going to drop compact index. First one. Let me drop other one also. I'll drop both. Both has been dropped. Now I'm creating index again. Create index one on this. I have created, right? So now I'm going to do alter. Let's look at here. Alter index name on the table. Look at here. Alter index underscore emp underscore index underscore index alter index name on emp rebuild. No, not this one. Terminal. Now index is not there. Indexes are not there. Let me first create index. So before alternating, I have to create index. This one. What it is telling is already exists. Index MP already exists. We have dropped it, no? We didn't. It's already there. Oh, compact still exists. drop index emp underscore index emp underscore index on emp. Press drop. No indexes are there. Let's create index. Index has been created. Now let's execute a alter command. Rebuilding. We have created this. Okay, let's query first, and I want to see a result. Select which of salary from emp. Let's see how much time it's taking. How much time it's taking? Let's see. Map is 100%. 42 seconds it has taken. 42 seconds it has taken. Now I'm going to execute rebuild, alter rebuild. Alter and rebuild. Let's look at how much time it will take. Done. No, it's actually we are not queried, we just altered index with it. Let's go here. Check in your HDFS how many indexes are showing. You can see here. Only one index is there. So now see here, after doing alter index, after you rebuild, it is showing something. So some directory it is. Just go back. This is some file it is. It is showing you here some mapping. It is showing some mapping. I also really didn't understand what is this mapping before. I think it is 5468. If you look at the data, I think it's similar to your data. Something is matching here. 54, 54, 1000, 2000. The 1000, 2000 was salary, and 346, 3456 also it's a salary. Okay, this is also salary. 4 records is showing here. Okay, I mean inequality it is maintaining, it seems. Inequality it has taken, and the location of the file. What is this 0, 12, 41, 20, 41, 25 or something? But not sure. Maybe it's the locations of. If you see here, after rebuild, we were finding some information here, right? So now go ahead and query this. Sorry, not here, there. The same query. Now check how much time it is taking. I feel now it should be little quicker. After alter rebuild, it is loaded the data. Before you just create index, it's not loaded the data, and after you rebuild, it's loaded the data. If you look at along with the positions, right? It's maintaining some data. Let's see. I feel it should be now. It should be a little quicker because we have created index and rebuild it. It's taken 48. So without index, it was taken. Without index, it was taken 56. If you remember, after index, after index, without rebuild, without rebuild, it's taken 42, and after rebuild, it's taken 40, 48. I mean, we're not able to see the exact, but it's close to 40 seconds, right? It means without indexing, it was taking 56 seconds, and with index, it is literally reduced. It will reduce a little bit, right? So if I go with other bitmap index, which is a little faster than the compact index, you'll get a more performance than that. So first, let's remove, let's drop the compact index, or else let it be that. No, not a problem. We'll see. No, we will drop it. I want to show you the no, complete difference between. I want to show you complete difference between the compact and this one. Anyway, we have this command show index. Why it is not dropping? Why? It's EMP index only, no? In the name EMP underscore index. EMP underscore index. Index if exists. Okay, no index is there. No index is there. Now create this bitmap index. Create bitmap index. This bitmap index is created. You can see here the bitmap index is created. Now we're going to go ahead and do that alter for the bitmap as well. Alter for the bitmap as well. EMP underscore this, the name. Or without that, first you query, select average of that. Without rebuild, let's go and look at here the HDFS. The index, the previous index has been removed because we have dropped it, and this index, so now nothing is loaded the data, and I'm going to rebuild it. So when I rebuild it, the data will be loaded. So now, as of now, without rebuild, altering and rebuilding, so there is no data, right? So once I execute alter and rebuild, the data will be loading here. That's what I'm going to show you. It is taking 34 seconds only. See here, where is your 48, where is your 34 seconds, right? Without indexing it was 56 seconds, and with indexing it's come to a little better performance, like a 48 seconds. And now with the bitmap we got the 34 seconds. We got 34 seconds, right? So now I'm going to rebuild it. I'm going to rebuild it on this, and it's actually loading the data. You can look at in this location. It's creating this directory. This is the, you will, I think let us finish this. This will be having some temporary data. I don't want to show that. This is done. This is actually, it's not performance. We didn't execute the performance. I'm just rebuild it. So when you rebuild it, the data will be reloaded here. Loaded here. So let's go back a little parent directory. If you see here, that has been created, the MapReduce result has been created here. So look at here, you found all the records with some information. So whatever the information it contains, and let's go back and execute now this after same command. So let's look at how much time it will take. So before it was taken only 34 seconds. Now look at this after rebuilding. Rebuilding in sense like you are rebuilding, you're building, I mean you are loading the actual data into the index after creating index in the indexed table. It's done. Map is one, and it is taken only 31 seconds. So without rebuilding, it was before it was taken 34 seconds plus. Now it is taken only 31 seconds. Right, so your bitmap index is a bit faster than your compact index because it maintains the, it's not only maintaining the index column, and it also maintains the index rows with the index rows with the in the rows and the block area as a map. You can look at here a rows as a digital image, your list of rows as a digital image, the value and the list of rows as a digital image. It will maintain that. Okay. So a bitmap is a type of memory organized image file format using the store digital images. So with managing this bitmap, we can redefine the bitmap indexing is given below. I mean steps and all. It stores the it stores actually the value of the specified column and the list of rows as a digital image. As a digital image, indexed column value and a list of rows. Indexed column and list of rows will be loaded into this. So let's go ahead and look at here. This is the value, the values of that and the locations where it is there, and the columns also. I think it is, these are the 1 2 3 4, and it is storing that information as a digital image. You may not able to find out what is this exactly, but it's some information is there here. Okay, so that's it for today, guys. So tomorrow we will be seeing UDF, UDF, UDAF, and UDTF. Once we complete UDAF, UDTF, and we'll be completing the Hive. So that's there in the Hive. So then day after tomorrow we'll be starting Scoop. Day after tomorrow we'll be starting Scoop. Yeah.